first question asks us, are the three types of discontinuity present? So we know the three types are jump, removable, and infinity. So no, all three types are not present.
Okay, for question 2, it asks, if so, explain where these points of discontinuity arise. And here we have jump, and this one right here is infinity.
For number 3, it asks us to explain which type is not present. So we see that we have jump and infinity, so therefore the removable is not present. And we know that removable is not present because no limit exists. A function has a limit as x approaches c if the one-sided limits are the same. So since we don't have that, we know that no limit exists, so therefore we don't have removable discontinuity.
Okay, and for number 4, it asks what is the domain of the function. And we know that the domain is all possible x values from the farthest left, which this point right here would really be -5, all the way to the right, and this one would be 8. So from here to here, your domain would be in brackets, -5, 8.
For number 5, it asks us what is the range of the function. So we know that range is our y values. So for this graph, we will particularly look at this line. And so this is negative infinity all the way. We're going to say this is 4. So we're going to stop right here since it has a closed point. So our range would be negative infinity to positive 4 with a bracket since it has a close. So for number 6, it asks us to use the continuity checklist to determine if the function is continuous at x equals 1. So first we have the function of 1 equals 2, so we're basically looking right here. We're going to say this is 2. Second is the limit of f of x as x approaches 1 equals 2. And we have the limit of f of 1 as x approaches 1 is also equal to 2. So since all three of these values are the same, we know that the function is continuous at x equals 1.
Okay, and then also asking you to use the continuity. Okay, and for the second part of number 6, it asks you to use the continuity checklist to see if the function is continuous at x equals -2. And so we do f of -2. And when you look at the graph, when you go up, we'll just say this is 3. So it'll be equal to 3. And then you do the limit of f of x when x approaches -2 will equal 1. I'm right over here. And then the last part, you do the limit of -2 as x approaches -2. This would be 1.5. And so, since they're all different, like, not like this one, but they're all the same, this one's continuous and this one's not, because all the numbers are different.
Number 7 asks us, does f of -1 exist? So if we look at our graph and we plot -1 right here, if we go up, we can plot our own dot, and so yes, f of 1 does exist.
For number 8, it asks is the function defined at x equals -2. When you go here, you don't pay attention to the open circle. So here there is a closed circle above it. So yes, it'll be defined. If you look across, it'll be 3. So yes, it is defined.
Number 9 asks us state how continuity and domain are related. So they are related because the domain tells you where the graph is continuous.
Okay, for number 10, it says determine where the function is continuous. And function is 5 over square root of 10x minus 2. And of course, you'll move this over to the side and make it positive. 5 by 7, x 1. So yes, the function is continuous, and it's continuous at infinity.
And this is our Types of Discontinuity podcast.